How's it going, everybody? And welcome back to our Cisco Enterprise series. Based off the recordings that we've done so far, just want to give a quick recap where we are. We have done a basic OSPF deployment in AS1. We've done a basic EIGRP deployment in AS2. And we've done a basic OSPF deployment in AS3. We then went ahead and did a full mesh of BGP peerings in AS1. We have a route reflected design in AS2, and then we have a full mesh in AS3. We have eBGP peerings between AS1 and 2, AS1 and 3, and AS2 and 3. We are doing route propagation. We've got a BGP peering between 33 and 26, and doing some local provider propagation, provider aggregated, meaning the provider is doing the advertisement for the customer on 42, 62, and 44. And we are doing a BGP peering between 22 and 29, and then a 61, 45, and 63 are advertising their local subnets into the BGP table for local route propagation. We also have 27 that is originating a default route to a quad 0 route to BGP for default routing via BGP for any of the customers that have a actual BGP peering stood up. So now that we've covered that, and that is I'm not doing full deployments, or I'm not covering the protocol in depth at one fell swoop. I'm breaking it up based off of where we're at. So if you're watching this in the playlist, then some things might be recorded out of order, but I'm doing that intentionally. So if you go through them in order, then it should be a full walkthrough of how OSPF works or EIGRP works. And in this case here, I've decided to go back to the HQ site, and we're going to be digging into some more of the switched campus topics. So I'm going to actually bring this back up, and we're going to go back to the CCIE blueprint. And I was reviewing the CCIE blueprint for switched campus, and we've covered just about everything there is to cover in switched campus. So what I'm going to do, instead of rehashing all these things and talking about them in depth, we're going to now look at it from an architecture perspective. How do we want to go ahead and deploy something? Because now that you have a baseline of how the technology works and how to implement them, now we can go ahead and say, okay, well, now take what you've learned and put it into practice. Simple as that. So what we're going to go ahead and do is we're going to talk about some of the different design options that we have for our HQ site. Now, we're not going to go through a full deployment in this video. There's going to be a lot of individual things. So what I've decided to do to make things, not necessarily to keep things interesting, but we're going to walk through some design. Before I get into the design, though, one device that I have to get stood up is Nexus 49, because Nexus 49 is going to be a core device. So I've got literally every routing capable device here in the core. So you're going to get your first dose of Nexus in this video. I'm going to walk you through on how to get it stood up, how to bootstrap a Nexus 9000V, and go from there. So let me go ahead and pull up Secure CRT, and I'm going to click on Nexus 49. That's going to launch this guy. So the Nexus itself is a data center class switch. So it is normally going to be used in the data center, and it's basically purpose built to be in the data center. There's certain things that the TCAMs are built for. It wouldn't really make sense to make this a what's the word I could use? It doesn't make a lot of sense to make this a core switch in your campus environment, because it's a data center based switch. So I intentionally am bringing it in here from a routing perspective so that you and I can go through and do some routing configuration on it, so we can test out EIGRP, OSPF, things like that, so you can see what it looks like to route on a Nexus 9K, in addition to up here in the The VXLAN topology, we'll be definitely diving into how VXLAN works. We'll be doing a VPC configuration because it allows me to show you guys what chassis aggregation looks like. So with that being said, I'm going to go ahead and I'm going to log into this Nexus 9K. We're going to bootstrap the device. So I'm going to go ahead and do an admin and then admin again. And as of right now, if we do a quick show run, I don't believe that I have. Okay. So when you first, actually, it'd probably make more sense if I went ahead and just bootstrapped one from the get-go so you guys can see what that looks like. So I'm going to drag this off screen real quick. And I'm going to bootstrap, because we're going to take a look at Nexus 50 and 51. So I'm going to right click here on Nexus 50. I'm going to start it. It's going to flicker a little bit. And then it boots. I'm going to click on it. So while this is booting up, I'm going to talk a little bit about the options we have for the campus LAN that we have right here. This campus LAN is not very involved, right? We have 2 distribution layer switches. We have 3 access layer switches. The distribution layer switches are effectively going to be where our default gateways sit, even though I've got it listed down here. They technically belong up here. So when you have a scenario like this, there is a well-defined architecture known as the collapsed core, where your core distribution processes are going to be running. So I've got 2 VLANs here, and I've got a handful of devices that we're going to be spinning up that will eventually be endpoints that we're going to be used for testing. But essentially what we have is the 2 VLANs. Obviously we're going to have to go through and on every one of these switches, switch 7, 8, 9, 10, and 11, we're going to have to configure VLANs 10 and 11. And then on switch 7 and switch 8, we are going to have to configure them as the default gateway for both VLANs. Now what's going to be interesting is if we go further up and we look at the core, which is going to be iOS, iOS XE, iOS XR, and Nexus operating systems, we're going to end up having to do some routing in between the distribution and the core. Now the reason why it's considered the core is because it connects to every other portion of the network. So that's essentially the key thing that you'll want to keep in the back of your mind when it comes to the operational nature of the environment. So from an architecture perspective, this is what you would expect to see if you were to walk into a corporate network. This is what I would expect you to see: a core connecting to they might refer to them as ag switches or aggregation, might be dist or DIST distribution, so on and so forth. But one way or the other, there is going to be a base level hierarchy that you're going to want to keep in the back of your mind. Now, for those of you that are going to walk into scenarios like this, where you have Cisco's SD access, where you've got the DNA center deployed, and especially if you're going to go after the CCIE Enterprise Infrastructure exam, you're going to be exposed to SD access. You're going to be exposed to DNA center. I can't really demo that, and there's really no platform out there. I am patiently waiting for DNA Center to be released as a virtual machine that's general audience, general availability, or GA release. It hasn't been released yet that I'm aware of. And if it has, I am not in the groups that have access to it. So when I go to Cisco's website to try to download it, it doesn't let me. So there is a variation of it, but it's a recovery image. The other one is the Catalyst 9K V is a beta release. So maybe they're going to make it like they did the Nexus 7K when they first rolled it out, and then they upgraded to the Nexus 9K and they made it actually a pretty good image for you to work with. So I've been able to demo a lot of things, fully stand up a couple of I should say not more than a couple, fully stand up several customer environments in a virtual lab just like this one and get things working. So if you have to work with an SD access, this is as close to SD access as I'm going to be able to get you. So we're going to be using VXLAN as the data plane encapsulation mechanism, but instead of Lisp, we're going to be dealing with BGP. And we'll talk about the differences between them from an operational perspective, but that's going to be what we're going to go do. And I've got a spine, 2 leaf switches, and 2 borders that we're going to be connecting to. So before we get to that, though, we're going to be seeing a pair of Nexus 9Ks that are going to be in what's going to be referred to as a VPC, or a virtual port channel. That's the Nexus equivalent to Cisco's VSS, or virtual stackwise. I will actually pull up some documentation and show you what that looks like, but essentially what they're going to do is they're going to join each other and talk back and forth to make sure that they can load balance traffic out of the LAN. So switch 12 will eventually form a port channel with N50 and 51, and then we'll get PC 82 and 83 routing. So I'm patiently waiting for the 50 to come online, and once it does, we'll be in good shape. But that's essentially what you have going on right now. Now, this will be layer 2 networking for Nexus. We'll do the exact same thing though. We'll have an SPI, we'll set up routing here. We'll get routing between 51 and 25 and 50 and 41. We'll get that all configured. And we'll be playing with a couple different routing protocols, EIGRP, OSPF, so on and so forth. So there's going to be a lot that we're going to be going over. It's going to be a lot of repetitive stuff though. So when I say repetitive stuff, meaning we're going to be talking about doing VLANs again, trunking, spanning tree, first hop redundancy through HSRP. I'm probably going to go VRRP. So let me pause that discussion for a moment. So what we have here is the power on auto provisioning process, and we want to, it basically says to continue with normal setup, skip, bypass password basic configuration, no, continue with power auto provisioning. I'm going to just type in yes, as I want to abort power on auto provisioning, which is a reach out to the network and try to grab your configuration from somewhere on the network and download it. That's essentially what Pope is attempting to do. So we're going to let that do its thing. This will take a couple of moments for it to trigger, and once it does, then we'll be able to go through and do the initial bootstrapping of the switch. So I'm showing you guys how to do this so that you will know what it looks like for an actual 9K. The configuration is almost identical to a physical 9K, so it'll make a lot of sense. So with that being said, once we get all of our layer 2, I'm just being patient there, okay, disabling power on auto provisioning, good. So once we get layer 2 completely done, and we're going to do this in a couple of individual videos and chunk it out, and we have that done, then we have this environment stood up and everything's good to go. What we're going to then do is focus on doing more advanced routing with EIGRP and OSPF. So I'm going to start off with EIGRP when it comes to scaling out. And one of the things that I'm going to be doing, and one of the reasons why I wanted to get the BGP routing done out of the gate when it came to the larger environment, was so that I'd be able to get an environment like this connected. So what we'll be able to do is, once we have EIGRP fully operational, we've tested out the scalability, we've tested out the K values, we've monkeyed around with the protocol, and we understand how it works. And then when we go to do DMVPN, and we have our hub routers, and we do let's say we take 58 and we connect to 22, 21, 24, 23, etc. And then we have our remote sites up here that are smaller. They'll all come into play. We'll have multiple spokes, and we'll be able to see what it looks like to run different autonomous systems over DMVPN and then locally inside of this location, and then run EIGRP over here. We'll see the scale, what it looks like, and how that's going to look differently. Because like I said, my goal isn't just to go through the blueprint, cover the technology, and then be like, poof, we're done. Because honestly, there's more to it than that. So we'll be walking through, okay, we'll fully deploy EIGRP, DMVPN, and we'll get it, basically simulate what you might see in the real CCIE lab, but be like, okay, in this particular case, for example, once we get EIGRP fully operational with one autonomous system everywhere, we'll do one autonomous system here, then we'll do one autonomous system over DMVPN, and then we'll do, if we have to do like redistribution or we have to enable EIGRP on the interfaces in order to get the routes to propagate, we'll do one big AS. So that no matter where you're at, you're always going to see internal EIGRP working. Let me pull this back up here. So do I want to enforce secure password standard? No. I'm going to set the password admin as admin. And then after a moment, it's going to ask me base configuration dialog. Nope, I'm good there. Don't need it. So then it's going to prompt me to log in. I'm going to log in. And then I need to look for the operating system name. So I'm going to go to global config. I want to type in boot, NXOS, boot flash. And I'm going to copy and paste this in right here. I'm using 9.3.10 code. And then it's going to go through a verification and compatibility check. This will take a couple of moments. So I'm going to move this over here while this is still working. So once we do like a single AS everywhere for EIGRP, then we're going to go take a look. What would it look like if we were to do two ASs? Like one AS at every location and then one AS over the DMVPN. Same thing with OSPF. We'll do one big area, then we'll break it up into multiple areas, so on and so forth. And then we'll have like EIGRP over DMVPN, but OSPF back here. How is that going to look? How do we control routing? What kind of issues could we potentially run into? Stuff like that. Like I said, this is not going to be this is how the protocol works, and we're done. You know, we're not going to walk through a handful of, say, 10 or 15 videos of how EIGRP operates, and then we're done. It's going to be more than that. Okay, so now that the verification process is complete, I'm going to go ahead and type in host name is going to be N50. And I'm going to come in here, and I want to give it an alias, because if I type in WR, it doesn't recognize that. So I'm going to type in CLI alias, name is going to be WR, and then the associated command. So essentially I'm putting in here an alias. And then I did copy run start, I type in WR, and then it saves the config. So that's going to be essentially how far we go with that. So I'm going to drag this off screen, and I'm going to start Nexus 51, but I'm not going to walk you through the individual steps the next time we do this. I'm going to let that boot up. Just like that. Okay, so now that we have that, let's go, and I'm waiting for Nexus 50 to come online. What I'm going to go ahead and do is we're going to talk more about what you can do here. So can you bring routing down to the edge? That's a question I've gotten in the past. Can you bring layer 3 down to the access layer? And the answer to the question is yeah. Well, not that far zoomed in. Yeah, you can. You can bring layer 3 down to the access, but that means that if you do that, then you're going to need to all your gateways are going to sit on the access layer. 2, you're going to have to take into consideration that any devices that are local to this switch, you could be in the same VLAN as. However, if you need to plug in, say, PC72 and PC70, needed to be in the same VLAN, but 2 different switches, the only way to make that work is if you had some sort of tunneling technique like VXLAN. Now, I'm not going to get super detailed on how VXLAN operates, but essentially, it allows you to extend layer 2 over a layer 3 backbone. So I'd be able to make switch 9 and switch 10 a VXLAN tunnel endpoint, or a VTEP, and then they would be able to ingest traffic from VLAN 10, for example. 9 would be able to take that traffic in from PC72, encapsulate it inside of VXLAN, forward it through the spines, 7 and 8, and then drop it on switch 10 that would decapsulate VXLAN and then deliver it to PC70. That's essentially how VXLAN will work. That's fine, and that's how this part of the network is going to work as well. But the reality of it is that in traditional campus, they refer to as classical Ethernet, it's not how it works. Not how it works at all. You're going to end up doing your layer 3 at the distribution layer, and then when you do that, you're going to run your gateways up here, doing some sort of first hop redundancy like HSRP, VRRP, stuff like that. And then you're going to run trunks down to your access layer switches. And you're going to have the same VLANs running on all 5 switches. So VLAN 10, 11 here, 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 and here. When you do that, you're going to have MAC address propagation. No different than what we did over here. It's going to be the exact same thing. The only difference is it's slightly larger. That's it. And we're going to be doing it over here so that we can get everything else for HQ operational that we want to have running. So that means that we're going to get the full deployment going here, Ether channels. I'm going to walk you through the config again and what we're going to be configuring, but it's going to be design related. It's like not going to be like explaining the individual syntax necessarily, but I'll be going over it again. Think of this like a CCIA lab that will be changing on a regular basis. I don't want to say constantly because there won't always be change, but we'll be discussing how you can implement certain capabilities in certain ways, and what if you were to see something like this? How would that be handled? If you decided to do something more interesting, how would you handle that? So, you know, rather than just not knowing, you know, I'm going to go over a lot of different topics that you may not have ever thought of before, but the more time and the more things you play with, and the more time you put into that, the more things you're going to learn. That's just the bottom line. So with that, we have the high level details of what's going to be going on with that. So what I'm going to go ahead and do is, while this switch is in the process of booting, we're almost there. What I'm going to go ahead and do is I'm going to start on switch 7, 8, 9, 10, and 11. I wasn't sure if I was going to be actually configuring something in this video, but I'm going to go ahead and do it. I'm going to go ahead and get the VLANs configured, and I'm going to get the trunking configured on all 5 switches. And this will be the first set of devices where we're going to have to use DHCP for our addressing scheme, because I'm not going to statically configure 6 endpoints. You'd never do that in the real world. We're not going to do it here if we can avoid it. So we're going to have to find some device here. The data center servers, I'm not going to trust. You know what I could do over here, since it's considered data center, I could add a server here, and that could be our DHCP server. Let me just double check on that real quick. So that's actually what I think I'm going to do. I'm going to go over here. I'm going to say node router, and I'm just going to put in here SVC for services, and I'll put a server here and save. The intention will be to, this will be its own dedicated subnet. Go from there. That might take a moment for it to respond, because I have this Nexus switch, which is actually good to go now. I'm going to say yes. I try to get that as quickly as I can so I don't have to sit there and watch the POP process go over and over and over again. So my goal here is to have a services router, so we'll be able to test local DHCP and then go over here, do DHCP relay, and we'll do stuff like that. So let me go ahead and get out of the way. I'm going to go ahead and walk you through the config of switch 7. Let me move this off screen real quick, because I need to open up switch 7, switch 8, switch 9, switch 10, and switch 11 in that order. Okay, so let me pause real quick and move these tabs around. Alright, so in switch 7, we're going to get these guys all squared away. Okay, so first things first, we're going to go ahead and give these guys a host name. The host name is going to be switch 7. Go ahead and give this guy host name switch 8. Switch 9. And switch 11. And then now we've got that there, I'm going to go back to switch 7. And I've got my 2 VLANs. I got VLAN 10 and I got VLAN 11. So I'm going to type in VLAN 10. I'm going to give it a name of even and VLAN 11 name is going to be odd, just to make it different. So I've got that going. I'm going to exit out of that. I'm going to do show history. And I'm going to take this config and I'm going to paste it on all of these devices as well, because they need to be there. Just like that. Okay, so now that they're all there, the VLANs are created. What I'm going to go ahead and do is for gig 2, 3, and 1.0 on 7 and 8, I do interface range gig 0/2 through 3, and then gig 1/0. Even though 0, 0, and 0, 1 theoretically are going to be trunks, so I'm going to come back to those in a different video. Or let me go ahead and no. Just get some of these Nexus switches up and running so that they're easy to work with here in just a moment. Paste that in like so. Alright, so I'm going to go in here. I'm going to come in here and type switch port, mode of trunk. Remember that you can't do this before you set the encapsulation mechanism to encapsulation.1q. If you leave it as auto, it's not going to work. So switch port trunk encapsulation.1q, switch port mode of trunk. Very simple. Do show CLI or do show history. We're going to go ahead and we're going to grab these few lines of config, run over to switch 8, copy paste. So that works for that. And then on switch 9, 10, and 11, I'm going to go interface range gig 0/0 through 1, switch port trunk encapsulation.1q, switch port mode of trunk. And do show history. We're going to grab these few switches, 10 and 11 respectively. So now all of our interfaces are configured the way that we expect them to be. Move this down to here. Okay, so we're going to host name is going to be N51 CLI alias name. Okay, so we're good to go there. So the last step that we want to do between 7 and 8 is configure interface range gig 0/0 through 1. And I'm going to come in here, channel protocol is going to be LACP. The channel group will be, what are my options here, 78 mode of active. Ether channel, oh that's right, I forgot to do. So it's going to be switch port trunk encapsulation.1q, switch port mode of trunk. So we'll go ahead and channel group 1 mode active. Okay, so even though it would allow you to do 255 different groups, it didn't like 78, which is fine. So we're going to go over to, no, it's telling us that the link isn't bundled on the other side. No worries. Interface range gig 0/0 through 1. We're going to switch port trunk encapsulation.1q, switch port mode of trunk, and then we're going to do channel group or channel protocol is LACP, channel group 1 mode active. So that's basically how you get all of that stood up. Fairly straightforward, right? Nothing super complicated. So now I'm going to admit that I've been doing this for a very, very long time. So this is, for me, is very, very easy. There's nothing complicated about this. So, which is why I'm walking you through the config. Yes, I did it quickly. That's because I've taken my time to explain in several other videos how certain things work. So if I do show ether channel summary, my gig 1 is not behaving. I might just have to give it some time. Do show ether channel sum. It's in standby. Do show interface trunk. Gig 1. I'll give it some time for LACP to figure itself out. So that's essentially what you need to do. So you can. So just a quick recap. If you're looking at this and you're like, okay, what do I got to do to configure this? It's actually very, very simple. I don't care if you're at a CCNA level or a CCIA level. The configuration is going to be create your VLANs. Then once your VLANs are created, create your trunks to interconnect your switches together. Do your LACP connectivity between your devices. And then what we'll do is on each individual switch, we'll go ahead and configure the individual interfaces. So let's do show run. Let me go ahead and get out of the way. Do show run interface gig 0/1. Okay, so that all looks correct. What about gig 0/0? The configuration should be the same. And it is. So switch 8. So it says it's waiting to be aggregated. Do show run interface gig 0/0 and gig 0/1. Okay, so what I'm going to do, and you get a situation like this, I'm going to go to interface port channel 1, and I'm going to shut down the port. Gig 0/1 will remain in standalone. Okay, I'm going to say no shut. If it continues to do that, I will go ahead and I will see if that doesn't fix it. There it goes. That seems to have done the trick. Do show ether channel summary. Okay, perfect. So, been doing this a while, so I know what to do to kind of try to fix it. So, the next stage will be to go down to the individual port level, and it's going to be a lot of repetitive config, but we're going to go configure the interfaces for the appropriate VLANs on 9, 10, and 11. So I'm going to go ahead and say interface gig 0/2, switch port mode of access, switch port access VLAN 10, and spanning tree port fast. And then I'm going to do the same thing for gig 3, so interface gig 0/3, be switch port mode of access, switch port access VLAN 11, and then spanning tree port fast. Okay, so do show history. So we're going to have those handful of commands. I'm going to grab Notepad, and like I did in the previous video, but I'm going to go ahead and open up a new tab. I'm going to copy this configuration out, like so, paste it here, and I'm just going to take this right here. I'm going to go to 10, copy paste, and 11, copy paste. Very, very simple. So if you're ever wondering how can I make the configuration piece of whether you're doing the small little lab simulets that you get in the CCNP core exam, I took the SP core 6 months ago, 8 months ago, something like that. And at the beginning of, well, actually no, it was probably end of last year. So I'm coming up on about a year since I've taken it. So I took the SP core because I didn't want to learn DNA center and wireless and a bunch of other automation stuff. So I just didn't have the bandwidth at the time to deal with it. But I needed to recertify. So what we'll end up doing is, in order to speed your configuration up in the little lab simulets for the core exam, or if you're looking to make yourself faster for configuration, you're definitely not going to want to try to configure everything device by device, if you can help it. It's definitely going to be advantageous or behoove you to copy things into Notepad and make little adjustments. But pay attention to the adjustments you're making. That's the big thing. So we have a fully, at this point here, this environment is fully layer 2. Like if I was to start bringing these these devices online, things would start to work. If I would give them a static IP, they'd be able to communicate with everything that I've done so far. The thing that we haven't done yet is we haven't given any gateways to 7 and 8, and that's going to come with time when we go to do the routing, because I'm going to turn routing on once this has been deployed, or once we get to the point where the 9Ks are good to go. That'll be the next video. I'm going to go ahead and up the Nexus 9Ks and get them deployed for VPC. I'm going to walk you through a Nexus deployment and how that'll work. It's fairly straightforward, but I wanted to get all of the campus, the layer 2 stuff done first, because you really can't do anything with layer 3 until layer 2 is operational. Even though technically speaking from here up is layer 2, our layer 3 will come in after that, and we'll be going through and dealing with those pieces. So it'll make more sense then when we do that. So that's what I really wanted you guys to see, is the hierarchy to it. That's also an example, another thing that I want to mention real quick. When it comes to your approach to labs that are like this, I mean, you're probably not going to get a lot of large you're not going to get a large topology like that unless you're sitting in for the CCI lab. Simple as that. Cisco's not going to test you on something this big at the CCNP level. So if you're looking for an order in which to do stuff, I always start at layer 2 and work my way up. And the reason why I do that is because layer 3 is dependent on layer 2 to be operational. If layer 2 is not good, layer 3 is never going to be good. So I try to build my networks, whether I'm doing a design, whether I'm doing an assessment, I always try to build layer 1 up. Try to understand the physical architecture first, how's everything wired, then I understand layer 2, where do the trunks live, where do the VLANs live. I try to kind of overlay that onto a topology so that it makes sense. So that's essentially what we're going to be doing here, minus a lot of like nomenclature at the interface level. We know that if you're going to be configuring, this is the gateway, and actually I'll move this up here and this up here just so that it's more obvious where the SPIs are going to sit. So these are things to keep in the back of your mind when you're doing this. So the layer 2 piece will get built first, then layer 3 on top of that. And I like to, when I do like diagrams and stuff, if I'm doing an assessment, I like to layer my topology like this. I have my layer 1 topology, you know, all the devices and then the physically attached connections. And then I like to do layer 2. Okay, is this a trunk? This is an access port. I won't obviously do access ports. I'm more concerned about infrastructure connectivity. So where do trunks exist? Stuff like that. Then where are my routing domains? Where does routing come into play? All that type of stuff. And it really helps when you can overlay the two on top of each other, because then you get an idea of where things are sitting. So jump back over here. So now that we have all of our devices configured, in the next video, I'm going to walk you through on setting up a VPC. I'm going to go ahead and I'll power on switch 12 while I'm here, considering it's right there. Might as well. So we'll get that done, and then that will give you guys everything from a endpoint connectivity perspective for layer 2. We'll get that fully deployed, operational in the next video, and then once that's done, you and I will be able to then focus on doing basic EIGRP. We'll stand up EIGRP in this environment here. We'll get everything connected so that once we get through EIGRP, we'll talk about we'll keep it fairly simple still, but we'll stand it up and get it working just like we did over here. You know, we're going to do the same thing here, but just a little bit bigger. So you got more moving parts, right? We're going to get all this connectivity in place and working. You'll have more moving parts, and then we'll go through and talk about the, you know, whatever it is that we need to discuss. So we'll go through that. It won't be really this is how EIGRP works again, but it'll be like, okay, we're going to stand up EIGRP here again, but it's like a lab. It's like Enterprise Lab 1, but way more thorough. That's probably the best way to put it. So that's everything I have for you in this video. If you guys have any questions, comments, concerns, feedback, drop that sucker in the comment section below. If you haven't already done so, please like, share, and subscribe. And I'll catch all of you fine people in the next video.